Yes, so I gave this talk last week at Java 1. It took an hour. I now have 35 minutes. So I'm going to be speaking pretty quickly during this session. The good thing is,
you can use 45, don't worry, Trisha.
Say that again?
You can use 45, don't worry.
Oh, well, that's fine. I'm going to try and aim for like 35, just in case. But YouTube does have a very handy way of slowing down and speeding up videos. So if I speak too fast, just rewatch it on YouTube. Great. So moving swiftly on, this talk is refactoring existing code to use Java 8 idioms. Basically, last year on Virtual Jug, I gave a talk called Java 8 in Anger, where I showed features of Java 8. I showed kind of how to build up a brand new application using Java 8. And sort of how you can use streams and Lambda expressions and so forth, how you can think about them to come up with new code, new things. But what I really thought is that most developers aren't working in that environment. We tend not to be doing greenfield development and certainly be in charge of greenfield development right from the start. What we're actually working with is legacy code bases, or, well, I say legacy, I mean existing mature code bases. So I wanted to have a look at what can existing code bases use from Java 8? How can it benefit from Java 8? When, how, and why should we migrate from code that works perfectly well to Java 8 style idioms like streams and Lambda expressions? But firstly, let's take a quick step back and ask ourselves the question, why Java 8? Because if you want to ask for time to do refactoring of a perfectly adequately working application to use new idioms, this is the first question someone's going to ask you. So we'll just run through some of the quick reasons why. I won't go into these in any depth, so we can move straight on. Generally speaking, Java 8 is faster. And there's a number of different reasons for this. One is there are performance improvements in many of the data structures you use, so they'll generally work faster, even if you don't use any of the new idioms or any of the new code. You also get some speed improvements with the fork join framework, and there's some changes to support concurrency which give you better performance too, if you're using those sorts of things. There's some more information about that in this link that's at the bottom of the screen. Again, I don't want to spend too much time on it, but if you start using the Java 8 JVM, you'll generally get speed improvements right away without even using any of the new features. Of course, Java 8 is easy to parallelize. That's kind of the point. That's one of the big selling points when we've been hearing about Java 8, the fact that you can use stream operations which can be run in parallel and use more CPUs, more cores, more easily. So you don't have to manage that parallelization. You get fewer lines of code, which for me, as someone who's been doing Java for years and years, maybe I don't really care about that. But you'll see through some of these examples that by getting rid of some of the boilerplate, you do get easier to read code, generally speaking, certainly once you get used to some of the new idioms. And there are new solutions to problems. By this, I mean a number of different things. One, Lambda expressions allow you to pass behavior around, not just objects. But obviously, you can use streams to solve big data type problems. And we always like to learn new things. So new solutions to existing problems, solving things that perhaps we couldn't have solved before or couldn't have solved very easily before. This is kind of one of the fun things about Java 8. One of the things I don't think we talk much about, though, is that Java 8 lets us minimize errors in our code through a number of different things. One underrated feature of Java 8 is optional. Optional lets you state up front, especially when you're returning it from a method, whether a method is going to return some values or maybe no values. So, for example, find me this customer. If you return an optional that is empty, then you know that's intentional, rather than a null value where you're like, well, I'm not really sure if it's supposed to be null or if this is a null which is snuck into my system somewhere. So optional is quite a good way to minimize unintentional errors. But also things like using the Streams API, it's quite an expressive way of doing programming. So you can be more explicit in the thing you're trying to achieve rather than talking about how you're trying to achieve it with for loops and iterators. And hopefully we'll see some more examples of this a bit later on too. But before we start diving into real-life code and real-life refactoring, it's really important to do a safety check before you refactor any code. The most important thing to have in place before you do any refactoring is good automated test coverage. Granted, you could also have a really dedicated QA team, but I wouldn't really wish that on anyone. It's a good idea to have a bunch of automated tests, unit tests, functional tests, integration tests, you name it. but good test coverage. If you're going to change code, if you're going to refactor, which means keep functionality the same way it was before, just express it in a different way, it's a good idea to have a bunch of automated tests there to prove that you are still doing the thing that you were doing before, and making some changes and wishing for it. I think this is particularly important for Java 8 because some of the new code looks quite different. And you can look at it side by side, the old and the new, and you can reason that the new code is doing the same thing. But without automated tests, you can't prove it's doing the same thing. You could do these tests as you go along, but it's a good idea if you've got tests done up front, so you have those defined before you start messing with any code. Similarly, I'm a big fan of performance tests, and I think performance tests are quite important, especially in an area like Java 8, where particularly using the Streams API, you might get some unintended consequences performance-wise from making these changes. Now, I don't necessarily mean, I know not everyone's working on low latency, high throughput applications, you're not all working on trading apps, but most applications have some kind of performance requirement, whether it's to respond to the user in a certain period of time, whether it's to not make too many calls to a database or across a network or so forth. There are performance limitations in any application, no matter what that application is. For your key areas, it's a good idea to have some automated performance tests to make sure that refactoring doesn't radically alter any of this performance. And I'll show you an example of some micro benchmarks I've done to show you where you might get unexpected performance changes when you migrate your code to use Java 8. Really importantly, though, when you set out to do refactoring, it's important to know what your goals are. And these goals for the refactoring could be anything you want to. It could be things like to improve the readability of the code. You could be trying to reduce the number of lines of code, which might be the same thing as readability, or it might be some other limit, like in Android, for example, you have a limit to the number of to the amount of code you can run on an Android device. So it might not just be about readability. It could be things like you want to improve performance and you think Java 8 will do that for you. It could be just a case of improving the education for your team. So it's probably quite a good way to upskill your team, to have them learn to use new idioms on familiar code that does familiar things in a domain they understand. This way, you're only changing one thing at a time. Instead of dumping a team on a new domain, new project, new technology, new Java 8, and have them learn everything. So this might be a nice, safe way to upskill your team. And very importantly, when you're refactoring, you should limit the scope of your refactoring. You should do it kind of, the examples I'm going to show are very much limited to a method level, but you should try and limit it to a method or a class or maybe a package. But try not to make a change that's going to crawl all over your code base into weird nooks and crannies that haven't been touched for decades, because you don't know what the impact of that will be. Obviously, if you do a refactoring which touches several hundred classes, you need to think about perhaps doing this in a slightly more strategic way rather than make a massive change like this. Now, the code we're going to look at is Morphia. This is a real-life piece of code. This is an object document mapper. It turns Java objects into MongoDB objects and vice versa. It's kind of a database driver / Hibernate type library for MongoDB. There's a number of reasons I've chosen Morphia. One, it's open source, so you can all take a look at it. You can look at the existing code, and you can look at the code after I've done some of the changes to it. Two, it's quite a mature code base. So it's kind of similar to lots of code I've seen whilst I've worked as a Java programmer in a bunch of different places. And you get those bits of code which have evolved over time, where you've kind of added this thing and this bug was in here, so you put this if statement in there. So it's not an example of perfect code, it's an example of real life code. So it's quite a good example for this refactoring. And three, it's a relatively small code base, so you can get your head around it and understand what it's trying to achieve. And so it's quite a good example for showing real life code that gets refactored from a Java 6 style to a Java 8 style. Right, enough of the preamble. Let's start talking about the actual refactoring. Now, as I mentioned, when I talk about refactoring, I'm talking about making changes to the code which should retain the existing functionality and largely the existing design too. I'm not talking about rewriting, redesigning, re-architecting. I'm talking about just refactoring small pieces of code. This is much more manageable and also means that generally it doesn't impact your tests very much. So you should be able to show that you're still doing the same thing, only before and the after the refactoring. The first area, the sort of quick win area we're going to look at, is using lambda expressions. And there are a number of sort of usual suspects we can look at for refactoring from anonymous inner class to using a lambda expression. These are things like Guava's predicates, comparator, runnable, callable, lots of these interfaces which previously, before Java 8, only had a single method on anyway, so now are what we call functional interfaces. Now they have a single abstract method, and when you're using them, when you're implementing them, you can use a lambda expression with no other change to your code. So let's dive straight in and take a look at this. Okay, so what I've got here is I've run a bunch of inspections. So I'm using IntelliJ IDEA, which is not surprising because I work for JetBrains. But the other IDEs, Eclipse and NetBeans, do have similar types of functionality to run code inspections and to do refactoring. So this is not a, you can only get this in IntelliJ talk. This just happens to be, I'm using IntelliJ IDEA's inspections and refactoring to achieve this stuff. Now the inspections, I'll put a link up at the end of the talk, which links to a page which has a number of other links in, one of which is a link to a tutorial on how to run these inspections. So I'm not going to go into that in any detail, but I've run a series of inspections that will help me migrate code from Java 6 style to Java 8. One of these inspections is anonymous type can be replaced with lambda. And in my code, I can see 3 places, well, actually 4 places, where I can replace an anonymous type with a lambda expression. Let's look at the first one. This is a Guava predicate class, and this can be turned directly into a lambda expression. So I'll do Alt-Enter, replace with lambda. All of my keyboard shortcuts, by the way, flash up on the bottom of the screen if you're interested. So I'm going to replace that with lambda expression. If I put this down here, what's happened is, here I'm bringing up the difference between the old code and the new code. It's basically removed all of the boilerplate, all the class type, the method name, the return type, the parameter type, and I'm just left with just the meat, just the thing which really does what we're interested in. And so I've just reduced all that boilerplate down, got rid of the anonymous inner type, and I'm now using a lambda expression. And I can be pretty confident that that's doing exactly the same thing it was doing before. I've got a couple more examples just to show this. One is runnable. Runnable is a good example because you might be using these in your code already. You can replace that with a lambda expression here, so you can see the same thing. It's boilerplate. I'm just left with the meat of the runnable. If I really want to, if reducing lines of code, improving readability is a core thing, I like to add static imports as well. So I can just remove them, which isn't super necessary. And the final thing here is we've got callable. This is slightly different from the other examples because this callable has more than one line of code. So I can replace that with a lambda expression, but I've got 2-line lambda expression. That might be fine. I might be able to reason around that. And in my personal experience, I personally prefer to have this refactored into a method. So I can say something like, I give this a useful name, and this is until found 10 items. So that's useful for describing what this is supposed to do. I get IntelliJ to refactor that as well. So I know what's happening there. There's another reason to do this, though, which is that stack traces for errors inside lambda expressions can sometimes be a bit, and if you've got these, if you've refactored this into a separate method, your stack trace is slightly more traceable. I mean, it depends on what you're doing, but I've personally found that multi-line lambda expressions, they can be more readable when extracted into a method. Okay, so that's kind of the easy stuff. So let's take another look at sort of the next level up. Lambda expressions can be used for interfaces with a single abstract method. They can't be used for abstract classes with a single abstract method, which might seem a bit counterintuitive, but that's the way it is. But what we can do is we can look for abstract methods which maybe could be abstract classes that maybe could be interfaces. So here I've run this inspection here, abstract class maybe interface. And if I look at this example, I have an abstract class, and it has a single abstract method. So I think this might be quite a good place to turn this into an interface from an abstract class. Class to an interface. It has a single abstract method, so I can tag this with functional interface. And then that says to me, this says to me that, I mean, it's just a documentation annotation, but this says to me that I can use Lambda expressions to implement this interface. So now I can look at some of the implementers of this interface. Let's look at this one. And now what I can do is I can turn that as well. So this way we can go through our code base, gradually looking for more and more places that we can utilize Lambda expressions rather than using anonymous inner types. That's all well and good and fairly automatic. You can use the IntelliJ inspections to do a lot of that for you. What might be more interesting is I want to look for patterns of code which might benefit from using Lambda expressions. This is a bit more complex than just saying, okay, anonymous inner type could be an interface, it could be a Lambda expression instead. This is like what bits of code would benefit from using a Lambda expression. I'll show you an example. And this might look familiar to you if you saw the last presentation. What I've got is, I have what's called a structural search. And my structural search, I will show you the configuration of this structural search. Okay, let's look here. Structural search is going to look for anything, it's going to look for logging of messages. So it's going to look for log of any level that takes a message. And what I want to do is I want to replace it with something which takes a Lambda expression, and you'll see why in a minute, hopefully. So let's take a look at the first example which pings up on this structural search. Log statement. I say log.debug, and I give it a string to log if the level is set to debug. Often what you'll find is you should see something like log.is debug enabled, and then that should be encased in there. And that might seem a bit weird, but most of us know probably by now that the reason why you do this is because debug is not enabled and you call this method. This still has to be built up. This string still needs to be created when you call the method, even if inside debug you're not actually going to use that string. So here, this is a list. So we're going to go to that list, we're going to build up the string for this list, we'll iterate over everything in the list, build up a string that represents that, append it to here, send it off to this debug method, and then do nothing with it if our log level is not set to debug. So this is a potentially expensive operation, which is why we quite often case it inside an if statement. And Roberta showed an example of that in the last presentation. So what I want to do is I want to change this. So instead of taking a string, it takes a Lambda expression which returns a string value. This, in fact, is a recipe of how to build up the string, not the string itself. Now this method doesn't exist at the moment, so we'll create this method, take a supplier, oops, always, a supplier, oh, now it's all broken. This is typical. Live demos always go wrong, and that's okay. So this is going to take a supplier of string. Let's call it string supplier. Now, this method now compiles. But what we will find is that we will find that any implementers of this, let's drill in, because this is an interface, and any implementers of this interface, any of my loggers, they're now not going to compile because I haven't implemented this method. Let's show them not compiling. We should see an error. I'm going to blame this on the weather. It's still insanely hot in Seville, and my laptop is really freaking out about the heat at the moment. You will know that an interface that doesn't implement a method is going to error. So what we need to do is I actually know what the default implementation of this method should be. I know what I want it to do. And I'll show you this. If we drill into this, I'm going to turn this into a default method, another new feature of Java 8. Showing you my errors now. Fine. Okay. Thanks for that. Anyway, turn this into a default implementation. I get IntelliJ to add a method body for this. Oh my goodness, what is my poor computer trying to achieve here? And my default is if is debug enabled, then I'm going to call debug with string_supplier.get. Now, only at this point does that string get built. Only at this point does it go off to the array or to the whatever expensive thing it is to build up that string. Before then, we don't incur any expense, and that's good because now this is wrapped inside this if statement. Then we only incur the cost of building up the string when we really need it. So that's quite a nice use for Lambda expressions. This way we can start taking Lambda expressions in our method rather than objects, and we can use that to do things like define a recipe for how to build up something so that we can defer the cost of doing that thing until we need it. So we can get some performance improvements from that. The other thing, and let's compile this so that we know it's working. The other reason why this is quite nice is if I show you another example. Let me find out where it is. Seven. The other thing is, if you've got the same 3 lines of code occurring all over the place in your code, you could get some copy and paste. Is I did not put this in the code to make a point. This was already in the code, and then we log it at info level. And this is not the only place where this happens. And this is very common. When you're copying and pasting stuff, you're going to end up with errors like this. I'm not sure whether really this should be a trace message or whether this should be is info enabled. Not getting what we wanted. But if we had this in a Lambda expression like this, and this if statement was folded into that method, then we've reduced the chances of copying and paste errors. That means only in one place, and it's only maintained in one place. So here, Lambda expressions are helping us to reduce the number of errors in our code. Seriously, my poor laptop. I demo on this all the time and it's always fine. Why is it deciding that now is a good time to grind to a halt? Right, on to the next example. So that's Lambda expressions kind of fairly briefly. Let's take a look at collections and the streams API. This is kind of where Java 8 can really start to shine. We can, of course, use automatic refactoring again. IntelliJ IDEA will look for places where you've got for loops or while loops, and for loops into either a collect statement or a for each statement, depending on what that for loop is doing. And IntelliJ can also work out whether you want to use the streams API or whether there's a relevant method on the collection itself. For example, for each exists on list. You don't need to do list.streams.foreach. You can just say list.foreach. And IntelliJ will work that out for you. So let's take a look at this example. Let's look for our inspection results. Here what we're looking for is for each loop can be collapsed with stream API. So here we see an example. This is kind of a classic example. What we do is we're going to iterate over a list of keys. We're going to find every key in that list. We're going to get the ID. We're going to put it into another list called IDs, and we're going to return that list. So we're collecting things from one list into another. So IntelliJ suggests we can replace this with the collect call. Dots on my stream operations because that's just a personal preference of mine. And now here we've got streams call where we are mapping getting the ID from that key, and then collecting into another list. The thing about this is that we still have quite a lot of boilerplate around here, but if I take a look, what's happening is this original IDs list is being initialized with set size. So I don't need to do that anymore, or at least I believe I don't need to do that. I think that might be an optimization, and I'm going to test the performance of this afterwards. So I can actually just get rid of this intermediate list completely. And here I'll just return that list directly. So now I've managed to, let's look at the before and after. We've got rid of our creation of an array, we've got rid of our external iteration, and we're keeping just the intent of the ID here in the mapping, and we're collecting into a list, and that's what we're returning. So we've simplified that code quite a lot. Let's look at another example. Here we have a much more complicated example. We have a for loop, followed by another for loop, followed by an if statement. So let's see what IntelliJ thinks we can do with this. It wants to replace this with a collect statement as well. To look a bit more complicated, we have a filter, a map, and a collect. And what we see is our if has been turned into a filter, and this add is part of the collect. What I might want to do, just to clarify things, is I might want to refactor this into a method. So create violation, and that way that might be a bit more readable to me. But even so, I'm a bit on the fence about this refactoring because I still have the for loop on the outside. So now I'm mixing idioms. I have a for loop on the outside, and I have streams here. And my removing the map into a method has kind of reduced some of my boilerplate. But I don't think I've really made a massive gain here. So what I actually want to do is, well, if you were doing this refactoring, you have a number of options. You might choose to take this because you're moving in a Java 8-ish direction. You've made this more expressive. Your if is now a filter, and you have a map. So it's a bit more clear what's going on with this particular piece of code. And you might accept this for loop around the outside and come back and refactor that later. You might want to raise a technical debt card somewhere along the lines. Or you might think, well, actually, I think what this is pointing out to me is this is a complicated piece of code. We're doing two sets of iteration. We're actually adding stuff into a list, which is a parameter, which is passed in. And so maybe I might want to refactor or redesign this whole thing. Simple refactoring, I'm going to raise a tech debt thing to redesign the way this works so that we don't have multiple iterations. So Java 8 here might not be the right choice to refactor to, but it might be highlighting to you that there are alternatives for your design. We still have a few more examples to look at. Now we're going to look at some, these were collect examples, so we're going to look at some for each examples. Here we have quite a simple for loop. We iterate over a collection, in this case a set, and then we call some method. So we can replace that with a for each. This whole for loop has just collapsed down into a single line for each, and then we're going to call this method for every one of those entities. I might choose to go a bit further. I might decide, well, entities is actually only used once, so I might want to inline this. Our variable is only used once, so I might choose to inline that as well. And then we've reduced all these lines of code into a single line of code. And this is very much going to depend on how readable you find this line of code. If this is useful to you, then you keep the full-on refactoring. If it's not, then maybe you just keep the for each. So let's look at another example of refactoring to for each. So I'm going to have to do this really quickly. Right. Oh no, let's undo that first. Have a look at this. We have an if statement, a for loop, an if statement, a for loop, an if, and an else. From the beginning, we're doomed. Because we have an if and an else, this can't be a single stream operation. We have two code paths that we can follow. So I know that this can't be collapsed into a single stream operation. But let's see what we can do with it. I'll replace this with a for each. Let's line up my values so I can see what happened. Here, my if and I have a filter, and I lost my 4, and I have a 4 each. But other than that, everything else is more or less exactly the same. And as well as that, we still have an if on the outside and a 4 on the inside. This is not a refactoring you want to do. It's not really gaining anything for you. Again, you might take a look at this and think, oh, well, maybe there's a simpler thing we can do with the design. So I won't do this small refactoring. I'm going to look at perhaps redesigning this and maybe getting better performance or better readability by doing a bigger redesign. I've got a couple more examples I want to show you on streams. So let's have a look at mapping validator. Another thing which can be collapsed into a collect call. Because what we're doing is we're iterating over one list and we're collecting values into a second list. So fine, let's go ahead and do that. Let's line up my dots so I can see what's happening. So now we're doing a map operation and collecting. But then what we do is we do a sort. So I'm creating a whole new list and then I'm doing a sort operation. Well, I don't need to do that. I can just say, and then I can remove that. And now everything there is collapsed down into a single stream operation. Now let's look a bit further on. What happens with this list? After I've created that list, then I iterate over that list and I do something. So now I have one operation which is creating a list and a separate operation which is iterating over that list. So I think I might just collapse that right down, use for each directly here, and I'll say logline.log logger. Here, this no longer returns anything, and this can be removed. Collapsed down a loop which creates a list, a sort operation, and a loop which iterates over that list into a single stream operation. And I think that's quite nice, certainly from a readability point of view, and I'm really interested to see what it's going to look like from a performance point of view. And the last one of these particular examples is something similar. I have a number of different things happening here, and maybe I can collapse this down into a single operation. So I'm going to replace this with a collect call. OTB lining up the dots again. Now what happens to this is everything from this list gets added into another list. And that's because this list has an initial size. Now I'm going to assume that initial size isn't that important, and I'll run some tests to make sure that's the case. And I'm just going to assign this directly to this. Okay, now what happens? Now with this list, then I'm going to turn that into an array. Okay, so perhaps I can do that outside of here. I'm not going to give that an initial size. I'm going to take this into a separate variable, field names, and then inline that. Looks like a single operation. I have stream operation here, followed by 2 array. But this is not actually a single operation. This is the sort of the builder, the configurator for the collect, for the stream operation. The collect is the terminal operation, which Robert was talking about in the previous presentation. And then once we have created this list, then we do a 2 array. So we actually have 2 separate operations happening here. The fact that we have dots separating all these different calls doesn't define that some of these calls do something and some of these calls don't actively do anything. But there is another way. Instead of doing this, we can do, let me see if I've got this right, because this is a new part of the presentation which hasn't been practiced before. We can do 2 array and we can say string new. And that will turn this directly into a string array. So we hopefully are skipping a step there. But again, we don't really know what's happening under the covers, so it'll be really interesting to see how that performs. Okay, so after that quick show of automatic refactoring of streams, what's next? Okay, what I really wanted to show you is some optional refactoring, because I think optional is enormously underrated and I think it has the potential to be very interesting and useful. However, I went through and tried to add optional to the code here many times, and every time I ended up changing like minimum 60 classes. I had optionals as parameters, I had optionals as fields, optionals as variables. I have loads of extra boilerplate everywhere. I haven't figured out a nice way to do this. So I think the lesson I learned with optional is you definitely can't go and sort of do a wholesale replace of optional in your code base. What you might want to do is new methods might want to return optional. So anyway, be warned, optional is a non-trivial refactoring. Right. I've implied a number of times that performance may be impacted one way or another with Java 8, but we haven't really had a look at this. So I want to have a look at this. There may not be lots of time for questions at the end of this talk. However, you can ping me questions on my Twitter handle. I may even pull together a bunch of questions and then answer them on my blog so that you can have a look at them later. So, performance of lambda expressions. What I've done here is I've done a test, which is a straightforward test between the difference between using an anonymous inner type and a lambda expression. The method we call with both of those is exactly the same method. So this performance test just tests the difference between calling using a lambda expression versus using an anonymous inner type. In this case, so with performance charts, sometimes high numbers are good, sometimes low numbers are good. So I wanted to make it clear that that in this case, high numbers are good, so you have a nice smiley face, and low numbers are bad. So the lambda expression outperforms the anonymous inner class in this particular case. Not by a lot, but it is better performance using a lambda expression. So if you did that automatic refactoring, you get better performance and the same, probably the same behavior you had before. However, of course, Oracle did a bunch of performance tests around lambda expressions to make sure they're not doing anything terrible with them when they introduced them in Java 8. And this example here, this is one of the tests they ran with one particular configuration of anonymous inner classes versus lambda expressions. And in this case, the lambda expressions didn't necessarily outperform the anonymous inner classes. So if this really matters to you, you need to do some performance tests around this. Okay, let's look at logging performance. I was really quite excited by the idea of using lambda expressions to do our logs so that we don't build up our log messages when we don't need them. So I've done a test where I have a method which calls a single string versus a method which calls a lambda expression with the same string. And then I have variable strings. So either one where we have to create the variable string and pass it into the message, or pass that in as a lambda expression. And what you find is that every one of those calls, except the one where you create the string every time, is the same. So creating a string that you don't need, creating a string that you're going to throw on the floor, is a very expensive operation and shouldn't be done. So either use the new methods on the new loggers, like the JDK logger does take a lambda expression, or create your own method which takes a lambda expression in order to make sure that you safeguard those calls. So now let's take a quick look at the difference between iterating and using streams. And here we've just done a simple, this is a simple normal for loop over a map versus a for each over a map. And in this case, the for loop performs the same as the for each. So you can do that refactoring without worrying about performance either way. Let's look at some of the examples of the code that we actually refactored. Here, there was a bit where I thought there was a premature optimization. So it's the array list already has a size. So I wanted to test that original code with the size against the original code without a specifically sized list against the new code which uses the string. And we find that the difference between the list which has a size and the list which didn't have a size, well, where we don't initialize it with a size, the performance is absolutely terrible. So that explains why they didn't do that in the original code. But the strings code performance-wise to the original code and a lot simpler. So we can do this refactoring probably without worrying too much about performance. Now here's the example where we had a for loop, an if statement, and we refactored part of it to use streams. And we find here, for some reason, the streams call is probably about half the performance of the original call. And I do not know why. And I'm really interested in this. So my plan this month of October is to go away and do some detailed analysis of this, because I honestly don't know why that performs worse. But to me, this is a very good reason why, if you care about performance at all, you do need to put some performance tests in place to make sure that something odd and inexplicable isn't happening in your code. Here's an example where we collapsed down a number of lines of code into a single line of code, and it performs more or less the same. So that's a fairly safe refactoring in that particular case. And what about this one? This is another one which is a combination of moving from a number of old for loops. We replace one of these old for loops with a filter and for each, but we still have the for loop. And here the performance is more or less the same. So you can't just assume that mixing the idioms is by definition worse performance. There's clearly something else going on here. The other thing to note for this particular test is this is operations per millisecond, and we're not getting very many operations per millisecond. So it could be that the operation that happens inside that loop is expensive enough to basically counter any gain or loss of performance of iterating. So in those cases, we probably don't care whether we're using streams or a for loop. Here, I really expected to see better performance. We're collapsing 3 different operations into a single stream operation. And we find the performance is more or less the same, which is kind of surprising. But in this code, the list that we're iterating over is a list of errors. And we're probably never going to have more than 2 or 3 errors, to be honest. We're certainly not going to have tens of thousands. So I think that the number of entries in your list is going to make a big difference on the performance of whichever approach you take. This is one where, again, we collapsed something that looked like multiple operations into what looks like a single operation, but actually it's not. You still have a stream operation and a to array. And we do find that the refactored code performs worse than the original code. Optional. I wanted to do some quick tests around optional. Doing a null check versus doing an optional is null or if null it just costs the same, because basically under the covers what you're doing is a null check. So you don't have to worry about any extra cost of doing optional there. However, if you do have to wrap a value in an optional, you are going to incur a cost of creating that optional value. So if you do introduce optionals into your code, you might be incurring cost of extra object creation. In summary, I'm going to try and whip through this really quickly. In summary, sometimes the new idioms decrease clutter in your code. For example, where we could collapse this down to a single line of code. But sometimes you find that introducing the new idioms doesn't necessarily improve things. In this case, we got more lines of code and not necessarily any more readability. Sometimes the new features improve performance. In the case of Lambda expressions, we got better performance in our cases. But sometimes using the new idioms means that we don't get better performance. In the case of this odd one, where we got half the performance by using the combination of for loop and streams, and we don't really know why that is. Sometimes a new feature makes life easier. For example, by introducing Lambda expressions into our log methods, we got a double win. We got a performance improvement, and we reduced any copy-paste errors. But sometimes the new idioms are not more useful. So if you go about optional the wrong way, you are going to end up with a mess of optionals and extra boilerplate all over your code base. Some refactoring can safely be done automatically using IntelliJ or Eclipse or NetBeans. And this is pretty safe, and you don't have to worry about the implications of this. But often, to get the most benefit out of it, you really do need to think as a developer, what more could I do? Or is this the refactoring I want to do? Here I've taken a whole bunch of code, go ahead and shrink it down into just into just 2 stream operations. And I could probably shrink that down further, because frankly, the fact that I have 2 stream operations implies that maybe there's something different I could be doing. Maybe this could be a single operation. So that was the summary, and I have a conclusion as well. Yes. Should you migrate your code to Java 8? Well, of course, it depends. You have to remember what your goal was. Was your goal improve performance? Was it improve readability? Was it learning for your team? So that when you start doing these refactorings, you can measure what the refactoring achieved versus what you wanted it to do. So you can say whether you want to go ahead with it or not. You have to understand what might impact performance. And if you're not really sure what's going to happen, you have to measure that performance. Your code may magically improve. It may reduce lines of code. It may become more readable. Or you might find that using something like the Streams API, for example, just exposes to you that your design might need some work, or there may be different ways to write that code. And your tools can, of course, help you, your IDE and other tools, but to get the most benefit from this, you need to be applying your good developer brain to it. Right, I am finally at an end. All the references are here at this URL. So you can see videos of this talk, you can see the slides, you can see the code that I've pointed to. There's extra articles that I've been referring to, some of the performance tests that I talked about that Oracle ran, plus my own performance test code is all there. Right, let's switch back to the Hangout. Right. I overran slightly, I'm so sorry.
Oh, no worries. Thank you very much, Trish. That was awesome. So some questions. We'll take just a couple of questions because we've got only a few minutes left before the next one. The question for Trisha. What micro-branching frameworks or approaches were you using to gather the performance information?
I was using JMH. It's absolutely brilliant. And I put links to JMH from that URL that I put in the end.
It's like the de facto benchmarking framework, pretty much, isn't it, JMH?
It is now. So talking about boilerplate, there's so little boilerplate to run micro benchmarks in it. It's absolutely brilliant.
One other question from Razorblade, and a big thumbs up to Razorblade and call out for him in IRC. Have you tried to parallelize the computation and got any performance stats from that?
Yes. In fact, I thought I had those stats in there, but apparently I didn't. Oh, let's see if I can just really quickly show you some of the... See, that's supposed to be there. It's not, though. So I parallelized a couple of things. I didn't parallelize the stuff for... oh, hold on. I share my screen. Oh, wait. And let's share that. Okay, so... parallelize all the operations I did. Ultimately, Morphia is a database driver, so the slowest part of the database driver is going to be talking to the database. However, I ran a couple of tests. This one is something like 64,000 things in a list, and I'm doing a map operation. If I do it in parallel, I get marginally better performance. So here, so this is in serial, this is in parallel. So running a map operation in parallel, I get marginally better performance for over 64,000 items in my list. This, if I'm doing find any, which basically returns the first result that matches some criteria, running that in parallel, the performance is significantly worse, because what you're doing is you're splitting out your data, moving it over multiple CPUs, multiple cores, in order to find one item, and you have to recombine all that stuff when you come back again. So the cost of going parallel for finding one item is often just not worth it. So it depends a lot on what operation you're doing and how many items are in your list. So for a lot of the examples I had, I really don't believe that going parallel would help.
Okay. One more quick question. I think maybe it looks like Dortmund Jog have a question. Yes, they do. One last quick question from IRC before we go to the Dortmund Jog, and it's what is the it was Mimic 47. Which Java 9, 10 feature are you looking forward to the most?
Ooh, I like that because I just did a Java 9 talk at Java 1. There's a couple of things I really like about Java 9. One is new methods on streams. So the ability to actually stop infinite streams, that's quite nice. And the other thing that's really nice is the new factory methods for collections. Like list of, map of, that's really nice. It's another way of reducing boilerplate. It's that last week, and it just really makes my code so much more readable.
Awesome, nice answers. So over to the Dortmund Jug. Quick question from Dortmund Jug.
Hey, can you hear us?
Yes.
Perfect.
Yep.
Did you notice any performance benefit by just switching from the Java 7 to the Java 8 compiler?
I didn't measure end-to-end performance. The problem with Morphia and the MongoDB Java driver, which is the other thing that I was working on quite actively, is that it depends an awful lot on the use case. So because it's a database driver, I wanted to see like what's the performance for 1,000 inserts, or what's the performance for a particular query. And that depends a lot on what your application is and who you are and what you're doing. So there's no kind of basic end-to-end test that I could do to say insert performance is, I don't know, 100 milliseconds, because there's no standard insert. And that would have been the best way to really figure out whether Java 8 would give us any performance improvements. And I didn't have any end-to-end tests for that. So the short answer is, in this code, no, because we didn't have any tests to be able to show that. I could probably do it with micro benchmarks, but I think that would be pointless. I think for figuring out whether the JVM is going to improve things, you really want a good end-to-end performance test and run it for quite a while.
Awesome. So I think we're pretty much actually right on time. So we better start there. So a couple of things. Trish, Stuart Marks is in the chat, and he's very, very thankful for the collections factory methods. Shout out.
Stuart, you did a great job.
So a massive thank you to Trish. Also a massive, massive thank you to Rabia as well for a great session just previously.